Here we go. So in bell work, two things here. Again, if it's on a bell work a couple days before the test, it's going to be important. It's going to be on that test. Okay, the first one says write the equation. Okay, so each one of these things needs to be in part of my equation. It needs to be a parabola. It needs to open down. It needs to be stretched by 4, right 1, and down 3. All 5 of those things got to be in my equation eventually. We just got to work our way to that point. Okay, so the first thing here says it's a parabola. Okay, if we're doing a parabola, Zion, what do I need to have in my equation to be a parabola? Square. Okay. As he does the x squared, remember, if we're writing an equation, it's a good idea to put a space in between there because there's probably something that's got to be plugged in. Done with parabola. Then we move to the next thing. The next thing in this equation says it opens down. So if my graph opens down, Gianni, what's going to be in my equation to open it down or to flip it down? Good, a negative sign. So he throws a negative sign out in front of everything. That opens it down. Okay, Brianna, next it says I'm stretched by 4. What am I going to do to stretch my equation by 4? Behind the negative, right in front of the parenthesis, right there we're going to put a 4. Remember, the word stretched or compressed mean the same thing. If I said it was compressed by 4 or stretched by 4, it goes in the same spot. Okay, the next one says I'm shifted right 1. If I'm shifting to the right 1, Dylan, what am I going to do to shift to the right 1? Add 1 where? In the parentheses, if I want to go to the right, is it going to be a +1 or a -1? Minus, good. He's going to go the opposite direction if we're going left or right. So we put a -1 there. And then the last thing is down 3. If I want to go down 3, no way, what am I going to add to my equation? Yep. -3, down 3, we tag a -3 on the end of that equation. Questions with something there? Same thing on the next one. Okay, the next one. Shania, it says a teapot graph. What am I going to include to make it a teapot? Square root of x. Got that part. Next thing it says is I'm flipped. Diamond, what am I going to put to make it flip? A negative out in front. Michaela, I need to go left 3. What am I going to add to my equation to go left 3? 3 where? Inside or on the outside? Inside. If I'm going left 3, do I want to put +3 or -3? Plus, because we're doing the opposite. So if it's left 3, that's a +3 in there. And the last thing I want to do is go up 5. Datrion, what am I going to add in my equation to go up 5? Yep, where's that going to go? At the end. Go up 5, we tag a +5 on the end. Those are easy problems if you know what you're doing. And if you can do that, then that means you can probably graph them as well. Okay? If you're struggling with that part, you need to get better at it because it's not only in there, but it's also in graphing. The next part is where we struggled a lot. We talked about this the other day. All right, let's do a quick reminder. When we're talking about domain, there are 2 things we're worried about. Okay, we're worried about fractions, 1 over something or 3 over something or anything over something when there's x in the denominator. What can I not have on the bottom of this fraction? This cannot be 0. It's not allowed to be 0 because if it is 0, then you're dividing by 0 and that is bad. Okay, so if it is a fraction, the bottom, the denominator, cannot be equal to 0. If it's a square root, what do we say with square roots? They cannot be negative because if they were negative, you would get an imaginary number and we can't graph imaginary numbers. So whatever is underneath the square root sign has to be greater than or equal to 0. It's always with 0. It's either not equal to 0 or greater than or equal to 0 to start. You just need to know where to go from there. Those are our 2 ideas. Everybody good with that? It's written on the backboard as well if you need it later. That's not going to be there on Tuesday, just FYI. So the first one, we ask ourselves the same question. Okay, on the first one, is it a fraction? Yes, it's a fraction. So if it's a fraction, Elizabeth, what am I going to do? Not equal to 0, because if it was 0, I'd be dividing by 0, and that is bad. Okay, to solve this thing then, Elizabeth, what am I going to do? Add 9 to both sides. So now x squared is equal to 9. And then take the square root. So x is not equal to, good, plus and -3 since I took the square root. That's what it's not. It is not plus or minus 3. What is it then? Everything else, all real numbers. Any number in the entire world, but plus or minus 3. That's what we just made that decision. My next one says 2 square root x plus 3. Okay, so we do ask the same question. Is it a fraction? Is it a square root? If it's a square root, we don't want negatives. So we're going to take that x plus 3, Yordani, and what are we going to do with that thing? Good. Greater than or equal to 0 because we want a positive number. So x plus 3 is greater than or equal to 0. Then we're going to solve it. So this is an easy solve. All we need to do is subtract 3 from both sides. X is greater than or equal to negative 3. Done. Questions there? Last one says x minus 4 cubed. X minus 4 cubed. We always ask the same questions. Is it a fraction? Is it a square root? What if I did this? What if I made it x minus 4 squared? Is it a fraction? Is it a square root? No, because what's a square root look like? It's a radical. It's not a radical. Okay, make sure we understand the difference. This is not a radical, not a fraction, not a square root. Then what's my answer going to be? All real numbers. Questions with anything there? Writing equations and finding the domain. Both things are very important.